Okay, so we're given parallelogram ABCD with diagonals AC and BD, and intersecting at M and P is the midpoint of MC. So then they want us to express AD as V and AB as U. Well, before I started working on the problems, I found what the diagonals were because I thought they were beneficial to us when we start going into the problems. So I said AC, this long one, is U plus V, because if I were to draw it out, it would be U and then V. And the resultant vector is this long line, which is the same as AC. And so after finding AC, I then found DB, which is just negative V plus U, or just rewrite that as U minus V. And that'll be this, which is the opposite direction of V, and then U, and the resultant vector is dB. And so the first problem, part A, wants us to find AM. So we know that M is the midpoint of AC because that's when the two diagonals cross, and that makes the midpoint. And so from what we know of AC, we can just write AM equals 1/2 AC. And substitute AC in with U plus V. So 1/2 U plus V. You can leave it as that or expand it out even more. Plus 1/2 V. Okay, so that's AM. Then for B, which is BD, from DB we can just write in, which it's the same thing but in opposite direction, so it's just negative DB. So BD equals negative V plus U, which is V minus U. For C, it's asking for CP, and so CP is this little segment over here, and we know that P is the midpoint of CP, so we can solve it in two ways, either as 1/4 negative AC or negative 1/2 of AM, because C and M, AM and CM are the same things. And so you go, there's a negative because CP is the opposite direction of AC and AM. I'm just going to solve it the negative 1/2 AM way, which is plus 1/2 U plus 1/2 V. Which is negative 1/4 U, negative 1/4 V. So that's the answer right there. And so for D, it's asking for DP, which is this pathway. That's dp. And we can tell that dp is a median of triangle DMC, which is just this plus this right here. So to write that, we can do dp equals dm plus negative cp, because mp is the same magnitude of cp, just in an opposite direction, because cp goes this way and we want mp to go this way. And so dm is practically just half of db, so negative 1/2 v plus 1/2 u is dm, plus negative 1 of 1/4 u minus 1/4 v, which is plus 1/2 u minus, so the negatives cancel out to make a plus, 1/4 u plus 1/4 v. And if you solve it out, it's negative 1/4 v plus 3/4 u, which is dp. And that makes sense because if you were to go negative v is pointing this way, and so negative v would point that way. So if you were to go to 1/4 of negative v, you'll reach m, and then if you were to go 3/4 of the magnitude of u, you'll reach p. So yeah.